Hi everyone, myself Praveena. I'm the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about the topic on question bank with module 4. Okay, module 4 name is Fourier series. Okay, there in that question bank we have 3 parts. First one is critical thinking questions, second one is long answer questions, and the third one is short answer questions. Okay, here the first part of the question bank is critical thinking questions. Okay, under that first one, find the Fourier series of the periodic function defined as f of x is equal to x, 0 less than x less than pi by 2. Next one, pi minus x, pi by 2 less than x less than pi. Then prove that f of x is equal to 1 by 4 by pi into sin x minus 1 by 3 square into sin 3x plus 1 by 5 square into sin 5x and so on. Okay, here once observe it is discontinuity function within the interval is 0 to pi. Okay, for the discontinuity function here 0 to pi by 2 function is x and pi by 2 to pi is pi minus x. Okay, here what about the interval 0 to pi? For the discontinuity function, what about the formula for that? F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin n x. Under that, we know that a naught, a n and b n coefficients. For that, first of all, we have to verify the Fourier series expansion according to the given formula, and after that, here the deduction part of the f of x. Okay, here what about the formula for that? F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus n equal to 1 to infinity b n sin nx. Okay, for that here a naught formula here within the interval 0 to pi means 1 by pi into integral 0 to pi f of x dx, and similarly a n and b n. Okay, by using these formulas, first of all we have to find f of x, and after that verify, here deduction part of that. Okay, we get here, okay, f of x is equal to 1 by pi into sin nx minus 1 by 3 square into sin 3x plus 1 by 5 square into sin 5x and so on. Okay, this is the concept for the first question. We discussed in the previous cases. Okay, go through that. Okay, next question. Here f of x is equal to pi, the interval limits minus pi less than x less than 0, x 0 less than x less than pi. Hence deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on is equal to pi square by 8. Okay, this is also discontinuity function, and here the limit points minus pi to pi. Okay, for that we have to verify, okay, according to the given formula, same as the first question, f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to b n sin n x. Here within the limits, here the interval is minus pi to pi. Okay, for that case, according to the given limit points, we have to write a naught, a n and b n formulas. Okay, after getting that a naught, a n and b n, for that we get directly that series. Okay, this is the second question. And the next question, if f of x is equal to 1 plus 2x by pi minus pi less than x less than or equal to 0, 1 minus 2x by pi 0 less than or equal to x less than or equal to pi. Then find the values of a naught, a n, b n. Same as the last questions. First of all, we have to find the series. From that series, we can get a naught, a n and b n values. Okay, next fourth question. Find the Fourier series of the periodic function defined as f of x is equal to minus k minus pi less than or equal to x less than or equal to 0, k 0 less than or equal to x less than or equal to pi. Hence show that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on is equal to pi by 4. Here once observe, here this is also discontinuity function. Here first interval minus pi to 0, for that case what about the function minus k, and 0 to pi the function is k. Okay, for that also same concept apply. For the same concept we get that series form. From that series we have to assume x value. Okay, after assuming that the corresponding value we get this series form. That about the fourth question. Next one, determine the Fourier series representation of the half wave rectifier signal. X of t is equal to sin t, 0 less than or equal to t less than pi, 0 comma pi less than or equal to t less than 2 pi. Okay, this is also same as the last question, same concept. Next, sixth question, let f of x is equal to t, 0 less than or equal to t less than 1, and the next one 2 minus t, 1 less than or equal to t less than or equal to 2 be a periodic signal with a fundamental period t is equal to 2. Find the Fourier coefficients of a0, an, comma bn. Okay, for that, okay, this is also same of last question. Here periodic function means what? Here they are given directly periodic value t is equal to 2. Okay, according to that we have to write the formula, and after that in place of t here we have to substitute 2 in place of t as 2. Okay, next one, seventh question. In the expansion of f of x is equal to pi minus x by 2 whole square, okay, within the limit points 0 less than x less than 2 pi. Then find the values of, only they are asking an and bn values. Okay, here what about the interval 0 to 2 pi? It will comes under full range or half range? It comes under full range within the limits 0 comma 2 pi. For that case what about the formula? F of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. Okay, this is the concept of the seventh question. Okay, for that here only we have to find directly an and bn values. For that, what about the formula of an? 1 by 2 pi into integral 0 to pi f of x dx, and 1 by 2 into integral 0 to pi f of x cos nx dx. Okay, this is the formula for the full length for finding a0. An means here f of x into cos nx, and this is sin nx dx. Okay, according to the given limits we have to take the limit points for the formula. Okay, this is the concept of the 8th question. And next, seventh question, sorry. And next, determine the Fourier series representation of the half wave rectifier signal. X of t is equal to t 0 less than or equal to t less than pi, 2 pi minus t, pi less than or equal to t less than 2 pi. Okay, determine the Fourier series representation of the half wave rectifier signal. For that 8th question here, once observe, okay, this is also discontinuity function. Maximum questions from the critical thinking discontinuity, but the interval length is here full range, that is 0 to 2 pi. Okay, for that we have to divide the limits and write down the formula for that. Okay, same as the first questions. Next, 9th question. Find the Fourier series of the periodic function defined as f of x is equal to 0, comma minus pi less than x less than 0, x square, comma 0 less than x less than pi. Okay, find the Fourier series of the periodic function defined as f of x 0 minus pi to 0 as the function, and x square 0 to pi as the function. Okay, this is also full range within the limit points minus pi to pi. Okay, if once observe here the limit points within minus pi to pi means, for that case we have to verify first of all the given function is even or odd function. Okay, if you are verifying even or odd function, okay, for that case easily we can can get the Fourier series. Okay, if the function is not an even and not an odd function means, for that case we have to find out a naught, an, bn. If the function is even means only from the Fourier series we can find a naught and an, and odd function means only we can find bn. Okay, for example, here the given function is even means, for that Fourier series only we can find out a naught and an. For that case only we get easily the Fourier series form. Okay, if the function is odd function means directly find out bn value. Easily we can get the Fourier series form. Okay, if the function is not an even and odd function, for that case we have to solve a naught, an and bn and substitute there, that is the Fourier series for the function. Okay, this is the concept. How we are verifying the function is even or odd function. Even means what? F of minus x is equal to minus f of x. Plus f of x. And here f of minus x is equal to minus f of x. This is odd function. If the function is even means f of minus x is equal to f of x. If odd function means f of minus x is equal to minus f of x. This is the concept of the ninth question. And next, last question from the critical thinking. Find the Fourier series of the periodic function defined as f of x is equal to minus 1 by 2 pi plus x, comma minus pi less than x less than 0, 1 by 2 pi minus x, 0 less than x less than pi. Okay, this is the periodic function expansion question. Okay, this is also discontinuity function, and here the limits complete full range minus pi to pi. According to that, write it as the formula and solve that expansion of the, you get the expansion of the Fourier series. These are comes under the critical thinking question. This is part A. Okay, next one, part B, long answer questions. Okay, what about the long answer questions? Here comes under, part B comes under 20 questions. Okay, under that first question, obtain the Fourier series expansion of f of x, given that f of x is equal to pi minus x whole square in 0 less than x less than 2 pi, and deduce the values of 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 6. Okay, this is a full range question, 0 to 2 pi interval. For that case, we have to find f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity b n sin nx. This is the function of f of x. Okay, for that case we can find a naught, an and bn values, and after that deduce the following. Okay, already we discussed in the previous case. Okay, same as that. And next, second question, find the Fourier series to represent the function f of x is equal to x cube in minus pi less than x less than pi. Okay, here once observe here the within the interval minus pi to pi means, okay, already I discussed minus pi to pi means what we have to do. Here we have to verify first the function is even or odd function. If the function is even means only we can find out the series from a naught and an. If the function is odd means only we can find out bn. Once observe here the function is f of x is equal to x cube. First of all, I have to verify that is even or odd function. Okay, according to the definition, f of minus x is equal to minus x cube, that is equal to x cube. That is f of minus x is equal to what? Minus x cube. Minus x cube means it is even or odd function, odd function. Okay, for that case, what about we have to solve for the Fourier series? That is only for find bn value. Okay, only we can find bn value for the Fourier series within the limits minus pi to pi. Okay, next, if f of x is equal to x in minus pi comma pi, find the Fourier series expansion of the function. Okay, here once observe same as the last question. Here the interval is minus pi comma pi. Here f of x is equal to x is also odd function. Okay, odd function. For that odd function we can find, okay, Fourier series. Okay. Next, fourth question, find the Fourier series to represent the function f of x is equal to e power ax in 0 less than x less than 2 pi. Okay, For that, f of x is equal to e power ax. E power x within the limits 0 to 2 pi means for that 0 to 2 pi, this is exponential function, this is full range. For that case, we can apply the first formula, what we discussed with the first question. That's the concept for the fourth question. Okay, next, fifth one, determine the half range Fourier series for the function f of x is equal to cos x for 0 less than x less than pi. Okay, here this is half range interval within the limit 0 to pi. For that case, directly given the question for the Fourier sine series. Here the function is cos x, but what about they are asking particularly for the sine series? For that particular formula, sine series already we discussed. Okay, according to that we can solve the given question. Okay. Next, sixth question, find the Fourier series expansion for the function f of x is equal to x square in the interval 0 less than x less than 2 pi. Once observe here, f of x is equal to x square. This is full range within the limits 0 to 2 pi. For that case, we can find f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus sigma n is equal to 1 to infinity bn sin nx. Bn sin nx. Here f of x is equal to x square. F of x is equal to x square means what? Okay, this is within the limit 0 to 2 pi. For that case, we can find a0, an and bn values. For the same question, if they are asking the limits minus pi less than x less than pi means what? For that case, definitely first of all we can verify the function is even or odd. Okay, if it is even means generally x square is even function within the limits minus pi to pi. For that case, easily we can find only a naught and an. Okay, that is particularly the concept for minus pi to pi. Sometimes they are given for the same question with minus pi to pi. For that case, first of all we have to verify that is even or odd function. Okay, and similarly, seventh question, find the half range cosine series expansion for f of x is equal to x square 0 less than x less than pi. Half range cosine series. Okay, within this is directly given half range and the interval limit points also 0 to pi. So that f of x is equal to x square. Okay, according to that formula, we have to write that formula and find out the expansion of the half range cosine series. Next, express the function f of x is equal to x minus pi as Fourier series in the interval minus pi comma pi. Okay, this is also full range minus pi comma pi, but whenever they are giving minus pi comma pi means for that case, first of all we have to verify that is even or odd function. That function is not an even and odd function means directly apply, find a naught, an and bn. Okay, first of all we have to verify this is even or odd. After that, go through the corresponding method. Okay, that is eighth one. And next, ninth question, find the Fourier series to represent the function f of x is equal to e power minus ax from x is equal to minus pi comma pi. Hence, deduce that pi by sin hx is equal to 2 into 1 by 2 square plus 1 minus 1 by 3 square plus 1 plus 1 by 4 square plus 1 and so on. Okay, this is okay. Here e power minus ax as the exponential function. From that, first of all find out the series and after that reduce the deduction part. Okay, and next expand the function f of x is equal to pi minus x by 2 whole square as Fourier series in the interval 0 less than x less than 2 pi, and hence deduce that 1 by 1 square minus 1 by 2 square plus 1 by 3 square and so on is equal to pi square by 12. This is also same as full range question. Next, find the Fourier series to represent the function f of x is equal to x minus x square in minus pi comma pi. Okay, this is full range. Okay, but already discussed minus pi to pi means verify first of all that is even or odd. Okay, and next determine the half range sine series for the function f of x is equal to x into pi minus x within the limit 0 less than x less than pi. Deduce that 1 by 1 cube minus 1 by 3 cube plus 1 by 5 cube and so on is equal to pi cube by 32. Okay, for that For that, here the function is x into pi minus x. Okay, here the half range sine series. Okay, directly given half range sine. Okay, for that, first of all, find out the half range sine series, and after that, we have to deduce the following. Okay, next, express f of x is equal to e power minus x as Fourier series in the interval minus L comma L. Okay, this is a different concept. Previously, up to the 12th question, we discussed only the limits within 0 to 2 pi, minus pi comma pi, or 0 comma pi. Okay, now the 13th question starts from minus L comma L. This is also same as last, but here this is, okay, arbitrary interval minus L comma L. Okay, for that case, what about the formula for that? F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity en cos n by x by L plus bn sin n by x by L. Okay, this is the formula. Okay, from that formula, okay, f of x is from that formula. Okay, this is the formula for minus L comma L, and after that, here within the limits a naught, an and bn, write it as that formulas and write on the series for that. Okay, that is 13th question. And next one, find the Fourier series of periodicity 3 for the function f of x is equal to 2x minus x cube in 0 comma 3. Once observe here, periodicity is 3 within the limits 0 comma 3. That means what? Here we have to compare with this 0 comma 2l. That means what about 3 here? Okay, that is 2l is equal to 3. From that, l is equal to 3 by 2. Okay, first of all, write it as L based formula within 0 comma 2l, and after that, first of all, we can find L value. Okay, that is here L value within the given interval. Comparing with that L is equal to 3 by 2. Okay, and after that, same as the last question, L based questions. Next, find the half range Fourier cosine series for the function f of x is equal to sin pi x by L in the range 0 comma L. This is also L based with the half range. Next, if f of x is equal to e power ax minus e power minus ax by e power ax minus e power minus ax in 0 comma pi, find the half range Fourier sine series for the function. Okay, this is also half range sine series. Next, 17th question, find the Fourier series expansion of the function f of x is equal to modulus of x in minus pi comma pi. Okay, here once observe expansion of the modulus of x. Okay, here the limits are minus pi comma pi. Here once observe, first of all, we have to verify modulus of x is even or odd function. Modulus of x is always even function. For that case, we have to find only a naught and an values. A naught and an values. Okay, after that, series is only f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos n x. Okay, this is the series for the 17th one. And next, 18th question, from the following function, find the Fourier series of f of x is equal to x plus x square in minus pi comma pi. This is also full range, already discussed. Minus pi comma pi means you have to verify is it even or odd function. According to that, you can go through the series form. Okay, 19th one, find the Fourier series of the periodicity phi for the function f of x is equal to 2x minus x square in 0 comma 5. Okay, here periodicity is 0 comma 5. Okay, here the periodicity is 5 for the function f of x is equal to 2x minus x square in, and that means here L value, L is equal to how much? 5. Okay, here L is 5, that is L is equal to 5 by 2. We have to compare with 0 comma 5 with 0 comma 2L, right? That means L is equal to how much? 5 by 2. Okay, same as this is same as which one? Already we discussed in the another question, same as that, that is 19th one. Okay, next one, 20th question, find the half range Fourier cosine series for the function f of x is equal to sin x within the limits 0 to pi. Okay, 0 to pi half range cosine series. Okay, write it as that formula and expand the expansion of the sin x. Okay, these are the questions comes under the long answer questions from the model 4. Next, part C, short answer questions. Define a periodic function for f of x and give example. Okay, these are important for the quiz. Okay, define a periodic function of for f of x and give example. What about the periodic function definition? F of x plus t is equal to what? F of x. Okay, if you are taking any periodicity of the given function, again we get the same function f of x. That is periodic function. For that, whatever the example, sine pi, sine 2 pi, sine 3 pi, sine pi is always sine. Sine 2 pi are the examples for the periodic function. Next, second one, state even and odd functions for the function f of x. What is even and odd function? Even means f of minus x is equal to f of x, f of minus x equal to minus f of x. This is even function and this is odd function. What about the examples for that? X square, x power 4, okay, like that, and cos x, there x cube, sin x are the odd function, and so on. Okay, these are the examples for the second question. Next, third one, find whether the following functions are even or odd. That is first question, x into sin x plus cos x plus x square into cos hx. Second one, x cos hx plus x cube sin hx. Okay, this is the, first of all we have to verify is it even or odd function. Okay, that is the answer. Next, fourth one, find the primitive periodicities of the function. Primitive periodic function means same as the first question. For that, we can find sin 3x, tan 5x and secant 4x. Next, fifth question, explain the Euler's formula in the interval 0 alpha comma alpha plus 2 pi. Okay, what about the formula for that? Here, if f of x is equal to a naught by 2 plus sigma n is equal to n to infinity a n cos n x plus sigma n is equal to 1 to infinity bn sin nx. Under that, whatever the formula, a naught is equal to 1 by 2 pi into integral, okay, 0 to 2 pi 1, okay, f of x dx, and similarly an and bn. These are the formulas for the beginning limits alpha comma alpha plus 2 pi. Next, write the half range Fourier sine and cosine series, okay, within the 0 comma L interval. These are directly from the formula based questions. And next, seventh question, write the example of the periodic function. What are the example for the periodic function? Sin x, sin pi, sin 2 pi, cos 2 pi are the examples for the periodic function. Next, eighth one, explain the Dirichlet conditions for the existence of Fourier series of a function f of x in the interval alpha comma alpha plus 2 pi. Dirichlet conditions means what already we discussed. Function is definitely continuous. And next, okay, some conditions are there in the basic concept of the Fourier series. Go through that. Okay, ninth one, what are the conditions of the expansion of a function for the Fourier series? This is also same as the Dirichlet conditions. Okay, these are theoretical questions. And next, 10th one, if f of x is an odd function in the interval minus L comma L, then what are the values of a naught and en? Already we discussed there also what they are asking, formula of the odd function. And next, f of x is equal to x square in minus L comma L, then what about b1 value? Okay, here minus L comma L within the function x square is even function, therefore no need to find bn value. Okay, 12th question, what is the Fourier series for f of x is equal to x in 0 comma pi? Okay, 0 comma pi means this is half range. According to that, write it as the formula. And next, 14th question, define Fourier series of a function f of x in the interval minus L comma L. Okay, this is minus L comma L. What they are asking, minus L comma L based series form. Okay, that is directly formula. And next question, if f of x is equal to x square minus x in minus pi comma pi, then what is a naught? Okay, here minus pi comma pi means this is full range. For that case, we can write it as the formula of a naught. Okay, next, explain the Fourier series for even function. Okay, even function means what? F of minus x is equal to f of x as given function. For that case, whatever the series f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos nx. Okay. Next, 17th question. Write about the Fourier series of the odd function. What about the odd function for that? F of x is equal to sigma n is equal to 1 to infinity bn sin nx. Here write it as the formula of bn. Next, if f of x is equal to x in 0 comma pi, then find the Fourier coefficient of a naught. Okay, write it as the series form and write it as a naught value. And if f of x is equal to cos x in minus pi comma pi, then find the Fourier coefficient of a naught. Okay, this is also minus pi to pi cos x as even function. Okay, for that even function, find out a naught value. Next, what about the last question? If f of x is equal to x cube in minus pi comma pi, then what is a naught? Here x cube is an odd function, so that we can find, okay, what is a naught? That is 0. Okay, f of x is x cube is even function, so that for that case directly, what about a naught value? In that function is odd function means only for the formula for the bn, there is no a naught, therefore directly that is equal to 0. These are the questions for the short answers and long answers and critical thinking questions. Okay, these are the questions from the module 4. Okay, thank you. Next class we will discuss with the other question bank questions. Thank you. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.